Oh.
Should probably think about getting on with this week's video. We haven't really got much time. Do you know where Mr. Barker is?
Yeah, I haven't seen him. I mean, could be anyway. I mean, he might be on duty somewhere. I mean, he's usually on duty about.
Yeah, standard.
Normal. Could be doing his register.
Yeah, again, standard.
Normal. Yeah.
On the other hand, he could be putting things on show my homework.
Yeah, standard.
Normal.
Yeah.
Yeah.
Oh. Ooh.
Well, what are we going to do in this week's video anyway? I mean, I don't know what we're going to do without him.
Don't know. I don't know. Usually we are a bit Barker for his drive, didn't he? He could have lost his drive. And
yeah, we might have to kind of fill in a bit.
yeah. Well, we could do like an impression of him. Like on our draw like faces on our hands, like can't be a bit childish.
Yeah. Don't think we should resort to that really.
It'd be good if we could do like an impression of like, alright, I'm Mr. Barker, bit of a geezer, bonzer, like that. You alright, Dad?
No. I've got this normal distribution problem. I've got this thing where it's normally distributed, but the mean is 3 and the standard deviation is 2. If only it was 1 and 0, then I could use the stuff from last week, but it's not. And Mr. Barker's not here to help me, and I just don't know what to do.
Oh yeah, where is Mr. Barker? Well, don't worry, I've got this sorted. Come and have a look at this graph.
So it better be good, Mr. Newton.
Right, okay then, Doc. So this is our standard normal distribution with mean 0
Okay.
and our standard deviation is 1. What was yours?
Mine had a mean of 3 and a standard deviation of 2.
Okay, so it looks like this. Now,
Okay.
you can see obviously the mean's high on yours. It's up here. If that was 0, then it's 3. It's more spread out
It is,
because
yeah.
you've got a high standard deviation. So
Yeah.
it's like gone a bit flatter, hasn't it?
Okay.
And it would be symmetrical down here, obviously, as well.
Yeah.
So you want to change that back into this thing.
I do, yeah.
Because then you can use what we did last week,
Yeah.
all the tables, reading off all those
They only work
probabilities.
for the standard normal distribution.
Yeah, and well, there probably would be tables for all them, but there'll be so many different possibilities. It'd be crazy. So we could change it back. So what I'm going to do, we're going to change the mean back from 3 back to 0.
Okay.
And we're going to do that by taking off 3.
Taking away 3, yeah.
So taking away 3, and watch the curve move. Right, so
Okay.
we're taking 3 off the mean, okay, and we've gone back and it's looking a bit similar now.
It is. Yeah. Okay.
So now I
Doesn't
want to.
quite fit though, does it?
No, it's because it's more spread out yours.
Yeah.
So we're going to make it less spread out,
Okay.
and I'm going to do that by seeing the standard deviation 2. I'm going to divide out all your values by 2. Okay.
Okay. Make them less spread out.
Less spread out, and look, bang on now.
Okay, that fits.
Okay. So let's recap. What did I do?
You took away 3, you took away the mean,
Yeah.
and then you divided by 2, so you divided by the standard deviation. So overall, you took away the mean and divided by the standard deviation.
Okay. What you need really is this formula, Doc. Okay.
All right. Okay. That
So-
looks nice.
Yeah, it's pretty. So X is all your like
That's
normal
my
distribution.
data.
Yeah, it's normal,
Yeah.
but it's not standard. So if you get your normal distributed stuff, you take off the mean, divide by the standard deviation,
Okay.
then you're going to get a standard
Okay.
normal distribution.
One which we've got tables for.
Yes. Okay. So we can use our values, change them, standardize them to standard values.
And so, are all the probabilities for this one? If I work them out for this one, will they be the same for that one?
yeah, they'll match up.
Okay.
Just
Oh,
like
that's
if
good.
we move around on the graph. And obviously it's important that we draw some pictures for this one.
Yeah, I think someone's got a good phrase about that.
Yeah.
Remember, guys, winners draw sketches.
It's winners draw pictures, you idiot.
Winners draw sketches. Winners draw sketches.
Right, let's have a look at part A then, using our idea about standardising. Now here we've got x, a random variable, and it's continuous, that has a mean of 50, so mu is 50, and the standard deviation is 4. Remember, it says 4 squared here because that's the variance, the 4 is the standard deviation. Okay, and we want to find the probability that x is less than 53. Well, let's draw a picture, definite picture. So there's our normal distribution, 50 goes in the middle, and we want x to be less than 53. Well, 53 would be about here. So the probability we want to find is everything less than that, so that is this bit here. Okay. So we haven't got tables for this, so let's standardise. So we've got z equals x, which is our 53, that's what we're interested in, minus 50 over the standard deviation, which is 4. Well, that would be 3 over 4, that's 0.75. So I'm going to draw an equivalent picture of the standard normal distribution then. So 0 goes in the middle, and 0.75, that is what 53 has turned into. And it's still this probability that I want to find. So you can see that these two probabilities are going to be the same. So if we want to find the probability that x is less than 53, that's the same as finding the probability that z is less than 0.75. But now, because we're using the standard normal distribution, we can just look up 0.75 in our tables, and it tells us that probability is 0.7734. Okay. Right, let's have a look at part B then. So, part B, we want x is less than 45. So again, I'm going to draw a picture. And 50 goes in the middle because that's the mean. This time 45 is on this side. And so if we want x less than 45, we want it to be this. Now, some of you may have noted this said x is less than or equal to 45. Because this is a continuous variable, it doesn't actually make any difference whether x is less than or equal to or less than. Okay, so that bit doesn't actually matter. So let's standardise. So we're going to do 45 minus 50 over 3, and that gives us minus 5 over 3. Sorry, over 4. That's 4, which is minus 1.25. Okay, standard deviation is 4, not 3, sorry. So, if we draw our picture, and that turns into 0, and so 45 we've seen as turns into minus 1.25. Okay, so we know that the probability of finding x is less than or equal to 45 is the same as finding the probability that z is less than or equal to minus 1.25. Now, unfortunately, we can't just look this up in the tables, because our tables only start at 0. Okay, tables only start at 0. So we've got to use the things we looked at last week to use the symmetry of the normal distribution. So we know that this probability is going to be the same as the probability is bigger than 1.25. So we know this is the same as the probability that z is bigger than 1.25. But how do we find this? Well, the tables give us the probability that z is less than something. So we can't look this up either. But we can look, if we work out 1 minus it, that will tell us what this probability is, and therefore this one. So if we do 1 minus the probability that z is less than 1.25, then that will tell us what this is. Well, if we look at 1.25, we get 0.8944, and so that's what all of this is, all the way down, not just to there, all the way down. And so when we do 1 minus that, we get 0.1056, so that must be this, and so that must also be that. Okay, and so that is the answer to our original question.
Okay, so in this problem, we've got a random variable y, which is normally distributed. We've got a mean of 20, and we've got a variance of 9. So standard deviation would be 3, the square root of that. So I'm just going to draw this distribution. Okay, so we've got our normal distribution. I'm not great at drawing the normal distribution, but it doesn't matter how good your diagram is. It looks roughly about right. And this is the y distribution. Okay, I know mean mu equals 20. I know that's my variance, and my standard deviation is the square root of that, 3. Quite a nice number. Okay. Well, we're told this. We've got to find the value of b, so that the probability y is greater than b is 0. Well, quite a small number, 0.06 something. Well, I think I've got to put b up here. Okay. Because it says y greater than b, so greater than it is quite small, so it must be down here. So I'm going to label that one. Okay. I can't do anything with this. What I've got to do, I've got to transform this into a standard normal distribution. Z, standard normal distribution. So I'm going to draw the standard normal distribution. This is normal, this is the standard normal one. So it looks the same-ish. So it'll be a normal distribution. Okay, looks about the same, whatever. Mean 0, standard deviation is 1. Okay. So there'll be a matching value here, the z value, that will have the area above it, the probability, to be 0.0668. Okay. Now, so I think about the tables. This is the 4 decimal places, so I'm probably going to be using this big table, okay? Because that's when you've got probabilities 4 decimal places. Right, okay, well, these probabilities work out the area before value. Okay. So what I'm going to do, the whole area, whole probability is 1. I'm going to take off 0.0668. And I'm going to use my calculator. Okay, and take your time with this. And I'll get 0.9332. Okay. So that's this area here. And so I can look at my table for that value. So I say, well, 0.9332, where's 0.9? It's right at the top here. So 1.5 is the corresponding z value. So that's 1.5. Okay, so these all match up. Now we've got a formula that will match everything up for us. Nice easy formula to remember. To get the standard value, capital Z, you take the original data, usually x, but we're using y. You take off the mean, and you divide by the standard deviation. Okay, so we've got the z value, the specific one is 1.5, and that should match up with the y value b. Take off the mean, which is 20, divide by the standard deviation, which is 3. Now we can all just solve that, times it by 3, and then we add 20. There we go, sorted. I haven't been getting any units or anything, so that should be super for that one. Key thing, always draw 2 diagrams. Your distribution that's normal, the standard one, and match it up. Use this formula to relate them both. Okay.
Right, so this example is slightly different because our continuous random variable x is this time normally distributed, but we don't know its mean. It just tells us that the mean is mu, but the standard deviation is 3. Okay? We're told that the probability that x is bigger than 20 is 0.2, so this time we know the value and we know the probability. So let's draw a picture. So, in the middle is mu, and if the probability that x is bigger than 20 is only 0.2, that's quite small. To be bigger than that, 20 must be up here. So that would be 0.2. Okay, remember there would be 0.5, so that's 0.2. Right, well normally what we'd do at this point is we'd standardise. So we get 0 in the middle, and here we would get whatever 20 minus mu over the standard deviation is. Okay, so 20 minus mu over 3. That's what we'd do. And that would get us this value here, where this probability would still be 0.2. Well, on our standard normal distribution, we can work out values from probabilities. And because this is a very nice probability, and we want the value that 0.2 is greater than that, that suggests to me we're in luck. We can look at the nice forward tables, because that has a nice probability and it's a probability that's bigger than this value. So if we look at it up, 0.2 came from a value of 0.8416. So this thing here must be 0.8416. So let's write that down. 20 minus mu over 3 is 0.8416. So let's do a bit of multiplying. Multiply by 3. We get minus 2.5248. Then subtract 20 from both sides. We get minus 17.4752. And therefore mu equals 17.4752, or 17.5 to 1 dp. Done.
Okay, so in this example, we were told we've got a random variable x which is normally distributed. So I want to draw that. So I do normal distribution. And this one's our x distribution. I know we're told mean is 50 in the middle here, and we're told that, well, sigma is sigma. I'm not very good at drawing sigma, so try and make them as good as you can. Flat bit and a circle. Okay. And let's put the information they say. They say the probability x is less than 46. Well, 46 is a bit before 50. That's 46 there. Probably before that is 0.22. So this area is 2119 to be precise. Okay, I can't do anything with that. To do anything with using the tables or anything, I've got to change it into a standard one. So let's draw a standard normal distribution. Same shape. Pish. And this one's going to have a mean of 0 and some deviation of 1. Okay. There'll be a matching value here that'll match up with 46. This is little z value. So little z. That'll have the same area. 0.2119. So we're back to what we did last lesson, and we've got to find out this z value here, because then I can match it up to 46. Okay. So let's have a look. I can't do anything with this. The main thing is, on these tables, right, I've got these for nice probabilities that go above the line. Well, I haven't got any of that. I'm looking above it and I haven't got a nice probability. These ones, 4 decimal places probability, and they're looking before the line we're after. Okay. But there's a problem. All these probabilities here are greater than 0.5. All the z values only work up here. So if I've got down here where I've got a negative z value, I just do a reflection. I've done loads of these. So if we reflect this just in the kind of like y-axis, flip it all over. There's an area here which is 0.2119, and that'll match up with our z value, but it'll be the negative of it. If that was minus 3, this would be plus 3, so it's the negative of it. Okay, you're still the same. Sigma's still 1. Now, I still can't work out on my table the bit after it. I have to do the bit before. So I'm going to do 1 minus this. Okay? Because that'll work out the value before. Now, obviously use your calculator. And I get 0.7881. Okay? So, that's the area here. I'll write it on. So I remember, it's that whole area there, including this bit. So let's look on our diagram, on our table, sorry. The area before, 0.7881. 0.7 is around here, 881, is that there? There it is. And that's at 0.8, so the z value 0.8 works here. Remember that's minus z, so our z value equals minus 0.8. Remember that makes sense, it's below 0. Okay. Right, let's connect these two with the formula then. Our formula to connect z you take your distribution x, you take off the mean, divide by the standard deviation. You need to know that. Okay? Let's put in what we got. Our z value is minus 0.8. And that matches up with 46 for the x value. Minus the mean. And divide by the standard deviation. Okay. Right then, so what we're going to do now is rearrange this. So I'm just going to times up by the standard deviation and divide by minus 0.8 in one go. Now you could use a calculator for this, and I would definitely in an exam, I'd always do it, but feeling brave, I can solve that. A good way of solving fraction division like this, times put on the bottom by 10. Okay. The minuses will get rid of each other. 40/8 is just 5. So it turns out that we've got a nice standard deviation of 5. It won't always be a nice number. They've made this example like it is. But this is the key. Your normal distribution, draw a standard one. Okay. Once you've got the standard one, you can play around it like you did when you first came across this. Work out the z value, and you can match it up using this form.
We should probably think about getting on with this week's video. We haven't got very long, have we?
Hello?
Is that Barker? Is that Barker? Is it Barker?
Where is he?
Ask him where he is.
Yeah.
What else was the impression of him as? He always does lots of things with his hands, doesn't he? Like, he's always like this. Yeah, he's always the geezer. We could put loads of stuff like that in.
Yeah.
If in doubt, sketch it out.